Hey YouTube, what's good? We are on differentiation. That's a very significant topic. So actually, I covered this topic within A-level maths, but today we will go through application, and in particular, we will have a look at economics. So basically, we'll go through several applications in economics, and that's going to be very useful not only for A-level students but also for IB, standard level, and higher level, because they definitely should have the syllabus, because that's new syllabus for 2020 and onwards actually, and that's why I decided to show how to differentiate and how to apply this tool in order to cover certain problems in economics, or might be in general in business. All right, so that's why the schedule for today's video is to go through differentiation and in general, okay, and then to apply that to explore like some things certainly related to finance. It's more about, total revenue, total costs, maybe profit, that you can figure out from those two parameters, and we'll have a look in a moment how to do that. And for now, there are 8 questions, just simple differentiation, and somewhere in the end you will see the 8 questions related to application in economics, but this is not the whole list. So actually there will be several videos onwards that covers another problems a bit harder, a bit complicated, but in general that's kind of like easy medium level. I'm pretty sure. Okay, that's no there should be any any complicated questions. So that's why for those who are still struggling with those like basic concepts and also in application. All right, so let's get into it. And of course, as always, you grabbing your notes and pens, trying to do by round, trying to differentiate, and I'll show you how to do that. All right, so that you can compare your answer with me. All right, so the general, as you can see here, there are lots of exponents, so that's why I'll give you the general rule for the exponents. If you do have coefficient and which is separated from x to the sum power n, and this is your function fx, and you want to differentiate, in other words, you need to take derivative dy dx. Sometimes it might sounds or it might look df dx, it doesn't matter. Sometimes you can use this notation as f prime from x. So both works. All right, so you need to apply this operator, and in general case that's going to be a times x, and n goes before, and the power you need to diminish by 1. This how derivative looks like. And make sure you remember that this also the gradient of the function fx at some given point. If you plug given point x0, you need to plug it here. Instead of x, you need to put x0 as well. All right, so hope you got those basics, and that's why I just set up as, general case or general rule of differentiation, so that you can always use that. And we gotta go through that. And the first derivative, so 9 goes before, it's going to be 27 in total, and you diminish the power by 1, so it's going to be x to the power 8. Let's go to the next one. So the next one is fractional, but it doesn't matter. Again, you take in y prime. By the way, it's called prime, so sometimes you can use the word like derivative, but sometimes you can like pronounce like y prime. That also works. Okay, so just you have a fractional power, but it doesn't matter. 5 over 2 goes before, so it becomes 15 over 2, because 3 times 5 is 15, and over 2. And you diminish the power by 1, so that's why from 5 over 2, which is actually, so 5 over 2 is 2.5, and you take away 1, right? Because you need to diminish the power by 1, so that's why 1.5 left, or it's going to be 3 over 2 left. Okay, so if you have several terms in a row, you need to apply for each term separately, okay? So that's why y prime in this case is going to be minus 6 times 2 over 3, so you'll get minus 6 times 2 over 3, and you diminish the power by 1. So 2 over 3 minus 1, that's again a very necessary skills is your ability to work with fractions. So 2 over 3 minus 1 becomes negative 1 over 3. So that's why you just write the power negative 1 over 3. And on top of that, you need to differentiate 6x to the power of 5 over 2. So that becomes 6 times 5 over 2. And as we did before, it becomes basically x to the power of 3 over 2. Okay. And finally, you need to multiply and hence simplify. Okay, so it becomes 6 and 3 cancel, becomes 2, 2 and 2, 4. So it's going to be minus 4x to the power of negative 1 over 3. And 3 times 5 after canceling becomes 15. So it's going to be minus 15x to the power of 3 over 2. As you understand, it's just repeating action. You just apply it to different forms. Okay, so now it's a bit different question. You need to find the gradient of the function at x equals 2. So what are you going to do right now? You take a derivative, okay? So in general form, first of all, it's going to be 10x. Now, because at x equals 2, as you remember, according to general way, that becomes the gradient. So that's the gradient, and you need to plug the point x equals 2. So that's why the gradient of the function y from x and y from 2 becomes simply 10 times 2, or simply 20. So the gradient over y prime from 2 is actually 20. And that's the gradient at this given point. I'll show you the sense of the gradient. So one more time, how the gradient works. As you can see, 5x squared is this function, right? At x equals 2, you simply need to do what? You need to, at this point, at this given point, here is the point where you actually apply, figure out the gradient, you need to use the tangent line. So that becomes the tangent line, and the slope, right, or gradient of this line becomes the same as the gradient of the function. So if the function y, so m in general equation mx plus c, that's the equation of the tangent line. So m simply becomes the gradient. So that's why you can apply this rule, and you better say that m should be equal to y prime from 2. Okay, so that's generic sense of what we are doing with the gradient. Okay, so hope you got it. It's not really complicated. It actually works in this manner. Okay, so hope you got it, how this works and how to interpret the gradient. So here I just technically do one more time, but in this case you have the fraction 2 over x4, so that's why first you need to lift up x, and that's why you need to use the negative power. So that's why I'll say that it's going to be x to the negative 4, because negative sign automatically makes the denominator to be numerator. And now you differentiate in the same way, so you take in y prime, it becomes negative 4 here, it's negative 8, and x to the power of negative 5, because you even more take away 1. So now you plug in x equals 2, and y from 2 simply becomes negative 8, and x, which is in this case 2, becomes to negative 5. Alright, so if you want, you can cancel, and I would recommend to do, because 2 negative 5 becomes 32 in the bottom part, and negative 8 over 32 becomes negative 1/4, or negative 1 or 0.25 if you like. Okay, so I hope you got how this works. Let's move here. Question 6. Find the gradient for x to the power 4 minus 10x. We'll do the same technically. It's going to be 4x cubed, and minus 10x. But because we're taking the gradient, we differentiate, so minus 10 left only. So now we plug the point, x equals 1. Whenever x stays, we plug 1, and we have 4 minus 10, which is negative 6. All right. So let's move to the next one. Question 7. Find all the points where x cubed minus x squared minus 2x has gradient of -1. So that's why I'll move next, and here separately we'll do, because I need to have more workspace, we'll do it here. Okay, so the question is about that you need to find all points, basically both x and y coordinates, where the gradient is -1. So first of all, we need to figure out the gradient, so that's why we take in y prime, and y prime from here becomes 3x squared minus 2x and minus 2. Okay, now we know the gradient is -1, so that's basically equals to y prime. So that's why right now we equate that to -1, okay? So this is -1, and hence we got new equation where 3x squared minus 2x minus 2 equals to -1, or minus 1 equals to 0. So basically you equate them. Okay, and now we need to solve this equation. I would use quadratic formula, and that becomes, as you remember, it's -b plus minus square root of b squared minus 4ac. That's what formula tells us to do, and over 2a. And I know each coefficient here. So if you struggle with those basics, but I'm pretty sure that up to differentiation you know it pretty well. But in the case you're not well, just try to visit. There are a bunch of videos related to how to solve quadratic equations. It's all about A-level, it's all about GCC. You can find those videos there, all right? So, and by the way, here is a suggested video you can see in the upper corner. All right, so now let's calculate. So it's going to be a plus 2 plus minus square root of, so 4 plus 4 times 3 becomes actually 16, and square root of 16 becomes 4, and over 2a that becomes over 6. So we've got x1 equals 2 plus 4, 6 over 6 is 1, and x2 point becomes 2 negative 4 becomes -2, so -1 over 3. All right, but this is not the end, because right now you need to find the coordinates, so you need to find the pairs. So that's why y1 corresponding to 1, simply you need to plug into this equation all the values for x that you got by step. So if x equals 1, you plug 1 here, and it becomes 1 minus 1, 0, and minus 2, so minus 2. So that's why the first point should have the coordinate 1 and -2. And the second point, so let's mark as P1. And now you need to plug x2 equals -1 over 3. So that's why P2 should have the coordinates -1 over 3. And whenever x stays, you need to plug -1 over 3. But I didn't do it in advance, so it takes some time. All right, I will use 033. So I'll use that. So cube, and I'll put the minus sign to it before, then minus 033 squared, okay, and minus 066, but it becomes positive finally, so plus 066. So what I've got around 0.5, 0.51, just around. Okay, so we've got two coordinates and for 2 points, and they're the points where the gradient is -1. So technically we can actually apply a more sophisticated tool. So it's all about, writing and drawing the graph x cubed. So there should be like cubic polynomial that goes in this way, definitely, because the leading coefficient is positive. There's more advanced analysis. And here what you need to do, you need to say where the gradient is -1. So basically where the gradient has a negative slope. Obviously it's here and somewhere here, and basically we've got those 2 points. All right, so it's that was the sketch. It's not precise, but I show you that actually we've got 2 solutions for that. All right, so hope you got it. And then let me see where I have pretty much more space. I think it should be somewhere here, so that's why I left for a while the top one and just come back in order to make 8. All right, in order to accomplish 8, sorry, you need to find the marginal revenue if TR is this one. So what does mean marginal revenue? Let's do that. There are 2 questions. And so marginal revenue is basically delta TR, where you have an increase in total revenue. So basically, it should be equal to the gradient or change of rates in revenue. So I'll write that total revenue prime from Q, right, because it depends on Q, and times delta Q. So where the marginal revenue becomes the rate of change. So that's why it's delta TR over delta Q. What it shows to you guys, so it's more economic terms and more maybe finance terms. So marginal revenue tells you it tells you how much the revenue will increase or decrease if you sell, let's say, extra 1 unit of production of goods. Okay, so that means your delta Q is simply 1, and the marginal revenue will indicate the increase in revenue after selling this extra 1 unit. All right, so how to do that? As you understand, it should be equal to TR prime from Q, or basically change of rates in revenue. So that's why we just simply need to differentiate that. Okay, so let's differentiate, and TR prime, you differentiate with respect to Q because now it depends on Q, on quantity of products sold. So that's why it becomes 2 goes before, it's negative 0.8 in total. Yes, if you multiply these 2 by 0.4, and Q, and plus 48. All right, and plus 48. That's going to be the marginal revenue when you simply, take a derivative, and it indicates their gradient or rate of change in revenue. Okay, so find the marginal cost function. So you again do the same, but in respect to costs. So it becomes simply 8Q plus 8, and derivative of the constant will eventually give you a 0. Okay, so that's the function of the marginal revenue and marginal costs. Hope you got it. So there are all of the basics, I must say that. So you can compare with what you have, guys. So that's the answers for each question, step by step. Maybe I'll just increase a little bit. And you can see all the answers up to 6. Here is going to be 7 solved separately, and actually the graph instruments was shown. And number 8, you can see just right here, and that's basically solutions for each question. All right, so hope you got those basics, and in the next video we'll go through a bit more complicated questions and videos. Again, this is very useful for all types of students, whether you're from A-level program or IB. Okay, so it's well to know, and it's good to know those stuff. Okay, up to the next video then. Peace.